Hi everyone, today I have brought a question from current electricity. Let's see the question. It says a bulb B is connected to a source having constant EMF and some internal resistance. So remember, the internal resistance of the source is not zero. A variable resistance capital R is connected in parallel to the bulb. If the resistance capital R is increased, how will it affect the first one, brightness of the bulb, and how it will affect the power spent by the source? So let's comment on these two. Now this is the circuit given. This is the source, a battery, and a bulb and a variable resistance. Now the EMF of the bulb is given to be constant and the internal resistance is not zero, remember. So a current I will flow, which will divide here, and then again it will meet here and I will flow here, right? So the potential difference here across the cell, remember, will not be E because there is an internal resistance. So the potential difference across a cell is E minus IR. Now why I calculated this V? Because to find the power consumed by the bulb, you can see this bulb is in parallel with this battery. So if this point is at 10 volt, this point will be also 10 volt, isn't it? Because this part has no resistance. Similarly, if this point is 0 volt, this point will be also 0 volt because this is just a connecting wire. There is no resistance. So therefore potential difference here, if it is 10 volt, here also it will be 10 volt. So if I know the potential difference, I can easily find power consumed by the bulb by using the formula V squared by R of the bulb. Now remember, R of the bulb is constant. So now let's see what happens when this R is increased. So when R is increased, what happens to the overall resistance of the circuit? Let's check. So the overall resistance of the circuit, R equivalent, just keeping in mind these two, will be equal to 1 by R of the bulb plus 1 by R of this variable resistor, right? So when this is increased, this whole thing will decrease. Now if this is decreased, this is constant, so this will also decrease, right? And if 1 by R equivalent decreases, it means R equivalent increases. So resistance of the circuit, the total resistance of the circuit, if I ask, it will be R equivalent of these two plus whatever internal resistance is there. So now since this increases, this will also increase. So if resistance of the circuit increases, the current in the circuit should decrease, right? Because the EMF is constant. What is the formula for current? EMF by total resistance, external plus internal, right? So since this is constant but R equivalent is increasing, the current in the circuit should decrease, right? Now if current decreases, from this equation what can I say? If current decreases, well, if this is decreasing and there is a minus sign, so minus decreasing will become more and more, right? So remember, V increases, and since V increases, if this V increases, power consumed by the bulb also increases. So the glow of the bulb will increase. So remember, the bulb will glow with more brightness as we increase this resistance. So in a simple way, let me tell you, when this resistance increases, the total resistance increases. When total resistance increases, current decreases. When current decreases, potential difference increases because of this relation. And when potential difference increases, the power consumed by the bulb also increases. Now I know some students might think, how can current decrease and potential difference increase? Well, they are thinking in terms of Ohm's law. Well, the potential difference across a cell is not controlled by Ohm's law. Ohm's law is applied to, remember, resistors, not for cells. And for cell, the potential difference is not IR, it is E minus IR. So when I will decrease, V will increase. So don't apply Ohm's law everywhere, right? Now what about power spent by the cell? Well, for a cell, the power spent is given by current into EMF. And since the EMF is constant, and here the current decreases because of increase of this resistance, the power spent by the cell also decreases, right?